Okay, so very briefly, I'm going to discuss the logical implications of the Pythagorean theorem. And those implications come from its converse, right? So if we said this was the absolute Pythagorean theorem, so if a triangle has sides A, B, and C, where C is the longest, and A squared plus B squared equals to C squared, that means it has to be a right triangle. So if we look at the converse, we would be saying if it's a right triangle, then uh, then its three sides A, B, and C would be equal to A squared plus B squared equals C squared, right? So what if we change? What if we change, several things here? What if we don't say a right triangle? What if we said acute instead, right? Or what if we didn't say equal to, right? What if we said is less than C squared, right? So that brings us into some interesting implications here. So we know for a fact if we draw a right triangle, right? So if I say, this side is 15, measure 90 degrees off that, and then say this side is 20, and we go ahead and close, right? We know this guy has to be 25. A squared plus B squared must be equal to C squared. And we know that's the case. 225 plus 400 will in fact be equal to 625, right? And that's because, we drew a right triangle. Okay, now here we have an example where that is not the case, right? So what happens when A squared plus B squared is less than C squared, meaning C squared is larger now, right? So let's say now we had a triangle that looked like this. Okay, so these two sides, let's say they're 16 and 18 respectively. And then this longest side here, let's say comes out to 26. Okay, so we see that if we do the Pythagorean theorem, so 16 squared, which is 256, plus 18 squared, I believe that's 324. Oops. Right? And let's see, 26 squared. That is 676. Okay, so 256 plus 324. That equals 580, right? And what that tells us is that 580 is in fact less than 676, right? So that means A squared plus B squared is less than C squared, right? And according to this conjecture, that would give us an acute triangle. Well, looking at this picture that we have right here in front of us, this angle right here, we'll just say it's unknown, it's theta, it's axiomatically greater than 90 degrees. That is an obtuse angle, and therefore this is not going to be an acute triangle, but an obtuse triangle. Okay, so we come to a really cool implication from that just by kind of delving into what if, right? And let's look at another one. Okay, so now let's say that we had a triangle whose three side lengths were, and I'll use a different color here. Let's say this is 20. Okay, and then let's say this is 24. Make it a bit longer here. And then this last side we'll say is 22. Okay, so I've got 20, 24, and 22. Okay, And actually, it looks like these might actually be a little backwards. I'm just eyeballing it, and now it looks more like this is the 24 and this is the 22. Anywho, right? So we're being told, well, if a squared plus b squared is greater than c squared, it must be obtuse. Well, we already know what gives us an obtuse triangle. That's whenever c squared is larger, right? So we know that this must be false. This must give us an acute triangle. Now let's see if that's true with what we have here, right? So is it true to say a squared plus b squared will be larger than c squared when you have an acute triangle? Well, let's find out. So 400, right, if I call this a, 22 squared, no idea what that is. 484, is it true to say that that is larger than 24 squared? 576. Absolutely. This is going to be 884, which is in fact much larger than 576. And we see every one of these angles, right? If I call this theta 1, 2, and theta 3, theta 1, theta 2, and theta 3 are all less than 90. And therefore, this is an acute triangle. Okay, so the generalization that we make here, the generalization that we will make here is that if we have a squared plus b squared precisely equal to c squared, we get a right triangle. However, if we get that a squared, b squared add together to something less than c squared, so if I get a squared plus b squared is less than c squared, we, however, get an obtuse triangle. Okay, and we see that, if we have a squared plus b squared is greater than c squared, right, where c squared is less than the other two squares combined, we see that we get an acute triangle. Okay, so these are the three logical implications of the converse of the Pythagorean theorem. So that does it for this video. Goodbye.